So in river swimmer problem, there is a river bed is given and there is a swim. The swimmer is trying to swim or trying to cross the river. Swimmer is trying to swim or trying to cross the river. What are the important parameters over here is that, let us say this is the river. So river has to flow with some velocity. Let us say the river is flowing with the velocity of VR. This is the velocity of river. And there is a boat or swimmer who is trying to row his boat or moving in a particular direction. So velocity of boat with respect to river, that is given, that is called the VBR. So let us say the boat is moving in this direction with the velocity of VBR. What is VBR? Velocity of boat with respect to river. And as a person, you are standing on the ground. Okay. So Brown, the man who is observing the boat from the ground itself, with respect to himself, the boat is neither moving with VBR nor with VR, but it is moving with some other velocity called the VB. Okay. So what is VB? VB is the velocity of the boat with respect to ground river. The person who is on the ground, he is seeing the boat is moving with the velocity of VB. Okay. So if I apply the concept integral over here, so I know that VBR number can be written as VB minus VR. Okay. So most of the situation in this type of problem, you are asked to calculate the velocity of VB. So what is VB? That is VBR plus VR. Okay. So these two vectors are to be added up. Okay. So VB is one vector, VBR is one vector, VR is another vector. So your answer is the addition of VBR plus VR vector will be the value of VB vector. So before solving this type of problem, so you have to be careful about the notation. What are the notations? So these are the notations. So VBR vector should be also VB minus. So the same concept can be applied for the river swimmer problem or river boat problem. Okay, same concept. Now VBR is what? VBR is called the direction along which the swimmer is tries to swim, or I can row my boat, or I am trying to row my boat along that direction. And in the direction which is the actual direction in which the boat is moving for the VB direction. So VB is what? VB is the actual direction in which the boat is moving. So there are different notations that are used to signify the VBR parameter. So VBR is one of the most important parameters for this type of problem. What is VBR? So VBR is either treated as the velocity of boat with respect to river, or it can be said to be as the engine speed, or it can be said to be the velocity of boat in still water, or a boatman tries to row his boat, or a swimmer tries to swim along. So whenever this type of statement comes inside the problem, so you must understand that these are basically the VBR parameter. What is VB? VB has one simple meaning, that it is the actual velocity in which the boat is moving as seen from the ground. And another important parameter is the velocity of river VR. Okay. So in 99% chances that you are asked to calculate the VB number. Okay. That doesn't mean that always you are asked to calculate the VB number. 99% chances that you have to formulate the problem to calculate the VB, and based on the given information you can calculate any of the parameters. Okay. Now, first of all, let us say this is the river. So D is what? D is the width between point A and VR is in this direction. So VR is towards right. So towards right means, so velocity of flow along that direction. So this side, let us say this is the side X side, and this is, let us say, the Y side. X is called the downstream side, or the downstream. X is called the downstream side. Okay, downstream. Y is called the upstream side. Upstream side. Okay. So along that direction, the river is flowing along here, and the boatman or swimmer tries to row his boat or tries to swim along the VBR direction, and VBR is making an angle theta with respect to the vertical. What is vertical line? Vertical line in the. So this is how you start to draw the diagram first. Okay. So once I draw this diagram, so I draw the VBR direction. Now once I draw the VBR, now from this point I draw the VR. Okay. Why? Because I want to calculate the vector calculation, that is VBR should be equals to VB minus VR, or VB should be equals to VBR plus VR. Okay. That means theoretically you have to add the two vectors. One is VBR vector and another VR vector. So first I draw the VBR vector. How to draw that? So for that, the angle theta is given to you, let us say. So I draw the VBR vector at an angle theta with respect to the vertical. Now from that point onward, I draw the VR. Now resultant of these two is nothing but this vector. So this is nothing but the direction of the V vector. Okay. Now actually you are trying to row your boat from starting from point A toward this point. Let us say I am saying it is B point. But due to the river flow, you are moving towards the point C. Towards the point C. So the distance traveled by BC length is called the drift. So I want to calculate the drift number. What is that X number? That is the BC. Okay. Now, first of all, you have to resolve the component. So at point A, if I make the component of VBR, if I make the component of VBR, so VBR has one component, that is VBR cos theta in the vertical direction, and in this direction there is VR. Opposite to that there is VBR sin theta. Okay, VBR sin theta. Now first we assume that VBR sin theta component is less than that of VR. First we assume that VBR sin theta is less than that of VR. So this component can be further said to be a particle is VBR sin theta, VBR cos theta. And along this, it is VR minus VBR sin theta. Okay. So this is the, let us say this is the X component, this is the Y component. Okay. So now X component is responsible to move the particle along X direction, and Y component is responsible to move the particle along the Y direction. So what is that Y direction? Y direction nothing like that, AB. So with that direction, with that velocity, the boat or the swimmer is crossing the river. So let us say D is the width of the river. Let us say D is the width of the river. So this D distance is traveled with the speed of VBR cos theta. So time to cross the river, T, is nothing but D divided by VBR cos theta. Okay. So this is the time in which the boat will cross the river. And within that time, what is the displacement along X? That is BC, that is our drift. That should be equal to how much? That should be equal to VR minus VBR sin theta multiplied by T. And what is that T? That is D divided by VBR cos theta. Okay. So that number will give the value of drift. Okay. So this is the answer for the drift. So what is drift? Drift is the displacement along the X direction. Now, you are trying to row the boat towards D. Because of the river flow, you are moving towards point C. Because of that, the drift becomes very okay. Now, a boatman tries to row his boat at angle 126. So, boatman tries to row his boat. Means this is the VBR. Okay. At an angle 127 degree with the river. That means in this direction, this angle is given as 127 with the river flow. So this is the VR. Okay. So VR is given as 14. You are asked to calculate the engine speed, that is VBR number. As per the nomenclature I know, this is the VBR. And time to cross the river T number. Okay. So simply try to resolve the component. So here what happens? VBR value is not given. So VBR, let us say I draw this number is VBR. Let us say this VBR. He is nothing but VBR. Let us say I am saying. Now here there is another VR vector is there. Let us say this is the 14. This is the VR number 14. Okay. And because of that, the boat is moving from point A to C. So what is AC direction? AC is nothing but our VB direction. Now, I know that the resultant of V and 14 is basically our AC number. So, what is V? So, if I resolve this, so this angle will become how much? 37 degree. Total angle is 127. So, 37 means this component should be V cos 37 means 4V by 5. That is 3V by 5. Okay. So, finally, what I can say that this is nothing but A situation where x component is 14 minus 3v by 5 and y component is 4v by 5. Why? I know that the part is moving towards point C, so VR must be greater than 3v by 5. Now, resultant of these two is making an angle. Let us say this angle is alpha. Okay. So, what is that alpha angle? Alpha is 400 by 400. If I consider the triangle ABC, so alpha becomes 45. In ABC triangle, tan alpha is 400 by 400. So, that means this angle is 45 degree. This angle is become 45 degree. Alpha is 45 degree. So, can I say that is 4v by 5 should be equal to this number? So, tan alpha that is equals to tan 45, that is equals to 1, and from the vector calculation I know that 4v by 5 divided by 14 minus 3v by 5, that is equals to 1. If I calculate it further, 7v by 5, that should be equal to 14, then v becomes 10. So that is our answer. So that is the image. So now the next question is time to cross the river. So river is crossed by the component 4v by 5. Okay. So T should be equals to D divided by 4v by 5. 4 into 10 by 5 means 8. Now what is D? D is 400 meter by 8. So 50 seconds. With the time of 50 seconds, after 50 seconds, the boat will cross the river. So this is how you have to deal with this. Understood? বোঝা গেছে? variety of problem. Okay, so boatman tries to row his boat 30 √2 meter per second. That means this number is basically the VBR number. Find actual speed, that means VB, and time to cross the river T. Okay, everything is given. Everything is given. So first to calculate the, let us say this number is VBR is given, that is 30. So this number is 30 √2 given. But now the angle is not given. Theta is not given. Theta is not. So what I do? So I know that the vertical component is basically 30 √2 cos theta. 30 √2 cos theta. Horizontal component should be right 70 minus 30 √2 sin theta. Okay. And resultant of these two is nothing but our VB number. This is the V vector. Okay. Now this is the direction in which the boat is moving. So this VB is making an angle as alpha. So what is alpha? Tan alpha is 300 by 400. Can I write tan alpha should be equal to 300 by 400. 3 by 4. Yes. Okay, 3 by 4. So this angle is alpha. So tan alpha is how much? 30 √2 cos theta divided by this number. So tan alpha, that is equal to 3 by 4, that should be equal to 30 √2 cos theta divided by 70 minus 30 √2 sin theta. Okay. So now this equation has to be solved to calculate the value of theta. Once I solve this, I get the value of theta. Once theta is known, then the time to cross the river or VV can be known. Because once theta is known, that is this component is known. Once theta is known, the y component is also known. So resultant of these two will give the value of VV number. So VV is known. And with that VV number, you can also calculate the time to cross the river. What is time? Okay. So the problem may be somewhat complicated because once you do this calculation of theta, it will take some time. Okay. So calculation of theta is difficult over here. Not difficult, it will be lengthy. So once I do this calculation, then only I can calculate the value of theta. Once I got the value of theta, then I can solve part. Okay. So this is another type of problem. Same problem. Now the value of theta is given. So last to calculate the same mean speed and time to cross. Okay. So you can solve this. Now I want to go for the another segment where I want to say what is the minimum time to cross the river. Minimum time to cross the river. So minimum time to cross the river. So earlier situation, what we got that time to cross the river T should be equals to D divided by VBR cos theta. Do you remember that? VBR cos theta. So this is the actual time that is there. Now in order to minimize this, that means this cos theta number should be maximized. So maximum value of cos theta is 1. Maximum value of cos theta is 1. That means theta should be equal to 0 degree. Now what was theta? Theta is the angle made by the VBR vector with respect to vertical. That means now the VBR vector become hard. Here can I say theta equals to 0 degree? So that is the condition where the minimum time is maintained. So for time to maintain minimum, VBR should be perpendicular to VR. What is the condition? Condition is that for minimum time, VBR should be perpendicular to VR. Once VBR is perpendicular to VR, then only I can say time required to cross the river is minimum. Okay, time required to cross the river is minimum. Under that condition only, the boat is crossing the river in a minimum time. In a minimum time. Now, next parameter is called the minimum distance. Minimum time is nothing but the minimum distance. What is minimum distance? So, minimum distance is how much distance you are calculating. So, the boat is actually moving from A to somewhat other point C. But now we want to calculate the minimum distance. So, for this minimum distance, so there are two categories of minimum distance. So, first category, let us use the category number A. So, for this category number A, minimum distance where I want to apply the concept that the drift is zero. Okay. So, here I say drift number, that is X number is 0. So, there is no drift. So, no drift means the VB should be pointed towards point B. Why? VB is the velocity of the boat, actual velocity of boat, that is the direction in which the boat is actually moving. So, I want to get the zero drift. Then VB should be headed towards point B. That means now in this situation, VB should be perpendicular to VR. Okay. So, for minimum distance, VB should be perpendicular to VR vector. And under that situation, in order to make that, so if I make the component of VBR, so VBR has one component, VBR cos theta. VBR cos theta. Okay. Another component, VBR sin theta over here. And VR is there. Okay. So, in order to get the only VB that is perpendicular, so that means you are only trying to get this component left. That means these two should cancel out. Okay. That means for minimum distance X to be 0, what is the condition? Condition is that VBR sin theta number should be equals to VR. Once these two vectors are equal, then only I can say that it has only vertical component. No horizontal component is left. So no horizontal component is left means sin theta can be written as sin theta is equals to VR by V. Okay. So if you apply this concept, that sin theta equals to VR by VBR, then only you can get the idea of minimum distance. And that can only be applicable when VR number is less than the VBR. Why? If VR is more than VBR, then sin theta is greater than 1. Sin theta can never be greater than 1. Okay. So that's why it's called the category number A to calculate the minimum distance. And in order to get the minimum distance, time is not minimum. Now, so for time to minimum, VBR should be perpendicular to VR. So minimum distance is not equivalent to minimum time. Both are different. So minimum time is one concept, minimum distance is another concept. Okay. Minimum time and minimum distance not same. Now the second variety of minimum distance. Now in the second variety, category number B, now I am getting the VR number is more than V. If VR is more than VBR, then the VB cannot be vertical. VB must be somewhat inclined. Okay. Now I am getting a drift value X. Okay. Now once I am getting a drift value of X, let us say I simplify this notation. Let us say I am saying this. I am writing VBR is let us say V and VR is let us say E. Okay. I am calculating with the notation VBR as V and VR is let us say E. So now I resolve the component of VBR and VR, and I can write the V vector as is equals to VBR vector plus V vector, VR vector. Now what is VBR vector? VBR vector is V cos theta j plus U minus V sin theta I. I'm writing because VPR, that is V, has one cos theta component upward and sin theta component in this direction. So U minus sin theta component. So that is the VV number. Okay. Now with that VV velocity, let us say I want to calculate the mode of VV number. So what is that VV mode? That should be equal to square root of this square plus this square. So V cos theta whole square plus U minus V sin theta whole square. Sure. This is the VV number. So once I calculate the VV vector mode, now I can calculate the distance AC. What is the distance AC? That distance AC is equals to mod of VV vector into T. In time T, how much distance is traveled? AC distance. What is that distance? That is VV into T. Now what is T? T is nothing but D divided by V cos theta. So that is this root number into D divided by V cos theta. Okay, that is the AC number. Now further simplify it. So it is under root V square cos square theta plus U minus V sin theta whole square into D, and I am getting this V cos theta number inside this root. So it is divided by V square cos square theta. Okay, that is the AC number. So if I simplify it further, so this divided by that number becomes 1. Okay, it becomes under root of 1 plus U by V square U by V 1 by cos 1 by cos means sec theta minus V cancels out. So sin by cos means tan theta whole square into D. Okay, so there is that. So that is the AC number. After simplification, I am getting this is the AC number. So in order to get the minimum distance, differentiation of this AC with respect to theta will be 0. Okay. So to minimize this, I am getting the DAC d theta equals to 0. Okay. So once I differentiate it, so differentiation of something under the root, that becomes how much? 1 by 2 root of something, that number. Okay, I am not writing that root number. Now I have to go inside this. So once I go inside this, U by sec theta. So that is U by V. What is sec theta? Sec theta is sec theta into tan theta. Minus tan theta. What is tan theta? Sec square theta. That number should be equal to 0. That is, this number is 0. So if I put the numerator to be 0, so 1 sec theta cancels out. So I am left with U by V tan theta should be equal to sec theta. Sec theta means 1 by cos and tan means sin by cos. So cos cancels out. So sin theta becomes how much? Sin theta becomes V by U. Okay, sin theta becomes V by U. So what is the combination? That is, it should be V by U. What is V? V was VBR and U is VR. So VBR by VR. Now that is simply opposite of the earlier. In the case number A, I am getting the situation that sin theta should be equal to VR by VBR. That means U by V. Now U by V. But here I am getting it is V by U. When I should go for the sin theta to V by U or U by V, that depends on whether V is more or U is more. It depends on the problem. If in the problem the value of V, that is VBR, is more than U, then you go for the first one. Okay. If V is more than U, the numerator is more than the numerator, in the case number A, for minimum distance. If V is less than the U, then case number V. Okay. So that means there are two situations where under that I can calculate the minimum distance calculation. Okay. So there are two formats of minimum distance, one format of minimum time, and one format of rate. Understood? Now, simply getting those results, getting those information, I know this number is basically V number, and this number is U number. Clearly V is less than U. V number, U number, so V is less than U. Okay, so sin theta should be how much? Sin theta should be 6 by 10. Nah, can I write it? Sin theta should be 6 by 10. That means 3 by 5. So sin theta is 3 by 5. Sin theta is 3 by 5 means that will be the whole condition of minimum distance. Huh? So sin theta means 3 by 5 means now in this situation what is happening? In this situation, the VBR, that is 6, is in this direction. And theta is this number, 37 degree. It is 37 degree. Okay. And VR is 10. Here is 10. Here is 10. Got it? Here is 10. So sin theta becomes 6 by 10. VR is 10. So can I say this is 6 cos 37 and this 6 sin 37. So 6 sin 37 means how much? 6 sin 37 means 6 into 3 by 5 means 18 by 5 and is 24 by 5. So ultimately what I can say, x component has 10 minus 18 by 5. So 10 minus 18 by 5 along x component and along y it means 24 by 5. Okay. So resultant of these two can be calculated as VB number. So once I know the VB number and with 24 by 5 I can calculate the T number. So what was T? T should be equals to D. D given 15 limited divided by 24 by 5. That will be the value of T. And once I calculate the VB number, so what is VB should be equals to 24 by 5 whole square plus 50 minus 80. 50 minus 80 means 32 by 5. 32 by 5 whole square. So that will be the VB number. Okay. So multiply these two, that will be the AC number. AC into VB into V. That will be the answer for the minimum distance. Okay. Because it comes from the category number B. Hey, it comes from the category number B. Why? V is now less. Okay, V is now less. So depending on the situation, you have to calculate which one is more or which one is less. Okay. লাইটটা দিয়ে রাখলাম বাবা। হ্যাঁ, অঙ্ক ভালো করে প্র্যাকটিস কর, তাহলে তৈরি হবে। এই জায়গাটা কিন্তু কঠিন আছে। হ্যাঁ, এই জায়গাটা ভালো করে, হ্যাঁ, ভালো করে প্র্যাকটিস করলে তবে হবে। ঠিক আছে, চলো তাহলে।